Разработок является средство, с помощью которых можно защищать автоматизированную систему управления.
Automated systems of control of technological processes, and I'm going to speak about it today. The topic and the composition of my presentation may look very basic one, but I would like to bring to your attention a very principal difference from common systems of info protection in the office network from those which are used and have to be applied to defend APCSs, automated process control systems, APCSs. Well, let's try to evaluate what is the main difference between APCS protection systems from office defense systems. First of all, the priorities are different. In the APCS systems, the main priority is the reliability of functioning, continuity of functioning, and while in corporate systems, the main thing is confidentiality. Availability versus confidentiality, and the automated systems of control, process control, APCS, the vulnerability of their functioning, the threat to their improper functioning could be a threat to life, to environment, and to significant threat to the business, because technological processes and the value of a minute of a process sometimes is very high and expensive, while for the corporate networks, first of all, these technologies in vast majority, they do not threat lives. Well, sometimes at the early years of office lives, there were researches done, that there were attempts made with the help of influence against the human psychology. They could somehow damage the health and life of people, but this is not specific to the office network protection. So the main problem is the integrity of data and loss of money. The APCS system has a very high requirement for forecastability, predictability of this system, because this system in main part of it is a real-time system. It's not always like that. It's not everywhere. It's a real-time system. Not all APCS systems are real-time systems, but nevertheless, many of them are. And it's a very important requirement. In the office networks, transactions, players who deliver the software for the industrial networks also are different. BP, General Electric, Siemens, Ikegawa, Honeywell, and other companies, including Microsoft. And for the office networks, main players are also the big ones, also big vendors, but they are different vendors. Speaking about protocols which are applied there, they, in their basis, have very usual and common protocols, TCP, IP, HTTP, but on top of those protocols, in industrial networks, they use big number of proprietary protocols and specialized protocols dedicated for APCS systems. If you will approach and look at these differences from the point of view of main principles, main targets that are being achieved by means of infosecurity. If for the corporate companies, there are three main objectives: confidentiality of data, integrity of data, and availability of data. For corporate network, these objectives, like confidentiality is the highest, but integrity and availability, they also are important but lesser priority. While for industrial networks, availability and integrity of data has the highest priority, and confidentiality very often plays an important role. But the priority as a rule is lower. In other words, if in office networks we speak about informational security, which means confidentiality of data, in technological networks, it's the continuity of the process. Even though this conference is mostly dedicated to availability and discovery of different threats and counterfighting them, not many people speak about it, but in my presentation I don't want to share a big piece of part to this section, but nevertheless I would like to say that automated process control systems very often are subject to attacks. This is not very often this information is published in mass media and becomes known to wide public, and the main reason you can understand, because the victims and victim organizations, they don't want to disclose this information to public, and generally speaking it's right thing to do. But nevertheless, last year we have fixed several cases when automated process control systems were documented. They have documented informational influence against such automated process control system. In January 2014, we have fixed a case, documented case, when through certain infected software upgrades, malicious code have penetrated into the control center of Monju nuclear power plant, and for a certain period of time it has existed there before administration have cleaned it, which has required certain efforts and time. In the summer 2014, there was another well-known attack against the company Black Energy, and Black Energy 2, Black Energy 3. It was developing, well, one of components of this virus campaign, Black Energy virus campaign, Trojan Havix, was distributed through the servers, OPC servers, and according to the witness of the respected organization, ICS CERT, it's the organization which shows the information about incidents and threats in the industrial networks. It's an American organization, of course. ICS CERT. They have announced that this Trojan, malicious Trojan software, because it was written with errors, it has damaged some OPC servers, which has led to a damage of continuity of the processes, technological processes. And in the end of the year 2014, in December, there was another significant penetration incident when German state information security energy have published an information about the fact that in one of steel mills in Germany, due to hacker attack against it, one of the main furnaces was not able to be stopped, and the information about it is not available still, and I have never seen this information in full detail, but we can assume what is to stop the domain furnace. Well, some statistical information that I would like to show you, and this statistical information is on the basis of publications which are available through the Kaspersky Lab. We have very big set of sensors installed in our network, and we gather information from those sensors. It's a cloud technology, and on the basis of analysis of the sensor-based data in our cloud, we can come to conclusion that on those computers where we have certain SCADA software being installed, we did find a number of vulnerabilities. Of course, this has to be taken into consideration because information from these computers which by their logical and physical location, they can deliver information to the internet. In other words, these computers, these are not specific computers for industrial facilities, but nevertheless, there's a big volume of information in those computers, and we can see that these computers, where this kind of software has a lot of vulnerabilities, including networking vulnerabilities, which have been used so long time ago. They still are present on those computers, and they have not been cleared in big volumes. So the lower graph shows you that the number of detected vulnerabilities is constantly growing and grows very fast. Well, if we look at these ICS CERT statistics, these statistics shows us that number of incidents, it's not vulnerabilities, but fixed incidents, and information about these incidents, sometimes public, sometimes it's not public, but this is a public report from American State Organization. And according to their statistics, the biggest number of incidents are in oil and gas industry, electrical energy industry, transportation, hydro and nuclear power plants, and main reasons for those incidents are a human factor. Operators or administrators, by misactions, they have improperly used software and hardware and leaked the information in the network. Well, looking at the same statistics, and these statistics also public statistics where you can discover it in the internet, and our specialists from Kaspersky Lab also published some of the statistics, and Sematic and McAfee also published this information, and it's a very significant. These are very significant numbers. The fact which is significant is that these well-known attacks, which tackle systems, APCS systems, are in a very concealed condition. For example, Stuxnet was discovered in the year 2010. However, it was active in a hidden condition since the year 2005. So in the course of 5 years, it was operating and nobody even knew about it. And similar statistics also tells us that similar situations, similar incidents of virus campaigns are happening in other industries. If you will look at this spreadsheet, you will see that from 3 to 9 years, sometimes this malicious code can stay undetected, which means that everything which happens right now in APCS networks and in office networks, because it's also related to office networks, everything which happens with these networks in our computers, well, we will learn about it in 3 to 5 years, about these virus attacks which are happening to them right now. So if we want to take measures of information security, well, this is very important, and especially this is important for the systems of automated process control systems, APCS. Once again, I would like to bring to your attention to those factors which very often prevent organizations from paying a lot of attention to information security measures. So the most common ones, the most common problems or the reasons due to which business owners or business designers or people who are responsible for business operations or people who must be responsible for security, they don't want to apply these information security measures. First reason, the common measure, is that they say that our system is isolated, our network is not connected to the internet, it exists as an isolated case, so due to this reason, we shouldn't take any measures to protect it. Well, out of our experience and out of the experience of our partners like Positive Technologies and many other research organizations which do pen testing and other similar studies, and this is also related to such a common opinion. This common opinion is specific not only for Russia, it happens globally. many and most of the business owners, owners of automated process control systems, they think that if their system is disconnected from the internet, they shouldn't take any measures. Well, the big number of researches and audits done with such companies tells us that informational channels do exist, even if there are air gaps, or even if the informational automated process control system physically is disconnected from the external networks. Even in this case, there are informational flows, and these informational leaks, they could happen through connected carriers or through the servicing organizations which come with their own notebooks to provide services or to provide regular maintenance to the equipment. The notebook that was brought into the automated process control system is an informational leak, which also means that measures of informational protection, they should be applied even in those cases where really networks physically are disconnected from the internet. Another situation that we often see in those companies is when automated process control systems are not isolated, but operators are confident that due to the fact that they have installed firewall, they have provided certain settings to it, and settings are not always perfect to those firewalls, and firewalls which disconnect the office network from the automated process control systems. But the firewall, it's also software, which also can have vulnerabilities, and these vulnerabilities can be exploited, even if it was well configured and if the networks are divided on a level of routers or any other networking devices. Our experience and our life shows us that the software itself and the switch itself is also software hardware device which has its own vulnerabilities, and these vulnerabilities are being exploited by the malicious code. Another myth which exists in the APCS world, it sounds the following way. Our networks are very complex. This equipment is not used by anybody else. Nobody knows about this equipment. So if nobody knows about this equipment, nobody can break it. Well, this is also an error. This is also a mistake. First of all, in order to break a complex system, you don't have to know about all its peculiarities. That's first thing. And the second thing, most of this equipment is available not only for that particular system, but also available for the research purposes. And usually it is very expensive equipment, and common platforms like AB or some other platforms, you can buy used equipment which will not cost such big money. So this myth is also a myth. Another opinion which exists in this world is that all responsible technological systems are equipped with fail-safe equipment, and this fail-safe equipment is able to prevent any failures. Yes, it's true, it can prevent a lot of failures, and this fail-safe equipment is reliable, and the experience of their utilization is experience which counts decades and dozens of decades, and they work pretty well, but they protect from those incidents whose experience is already well known to us. In other words, the fact is that IT systems, information systems, and their vulnerabilities present a new phenomenon. And this is a new phenomenon for the world of APCS. What does it mean to us? Well, I can make an example. There is no fail-safe system which will prevent switching on and off electric networks with a frequency 50 hertz or 20 hertz. So nobody can imagine that somebody will do something like that and will move the switch with such a speed. People have not been doing that like that before, so there was no fail protection because of that. But helping, well, with the help of automated control systems, this can be achieved easily. This is number one. Number two, the danger is not only the faults or incidents, but the danger can be in the wear of equipment. The access have shown us that all these fail-safe measures been taken in that plant, they didn't work in a case when one turbine or centrifuges, they have been working in critical modes and they just simply worn off. They have not been exceeding above the fail-safe zone, but the time of their operation was much higher than calculated time for their operation. This is also an attack against such systems. So what I would like to tell you, the fail-safe protection, well, you shouldn't rely on it if you speak about threats from the point of view of informational control systems. And another common myth, maybe it's less common today, some people think that, well, our facility is located so far away, it's a small transformer, who needs to break it, who even wants to do any attacks against it? Believe me, as for informational system, this opinion is a wrong one. And the fact is that, truthfully speaking, even though if this object is not in a framework of interests and is not significant to big fraudsters, and the fact that there are dozens and dozens of thousands of those objects, but the fact is you also have to understand that informational technologies, they have such a property as high repeativity, and it's easy to repeat the software code. It's difficult to develop for the first time, but it's easy to repeat it. For development, you need qualification, you need specialists, complex equipment, but after this malicious code was developed, its utilization, its repetition for any other malicious purposes, well, believe me, it doesn't need any effort at all. And we do know a lot of examples like that. For example, the same Stuxnet. An conclusion we came after it tells us that all these complex, well-developed software modules, in 1 year, they started appearing as a software which attacks bank remote systems, ATMs. So they've been taking those modules, and these modules that were available in the internet have been used for their criminal purposes. So once created, malicious code can easily be copied in thousands, which tells us that it's not necessary to be a target to become a victim. So the most negative part of all these stories is that you cannot feel yourself protected if you don't take any protective measures. And right now I would like to speak about which technologies could be used by us. In the beginning, I've been telling you about the differences, and then I've told you about a big set of dangers and threats, and right now let's speak about how should we properly protect ourselves, which methods should we apply, if office methods are not applied, which other methods we should use. And this reference-based model that was given in the standard ISA 95, ISA 95, this is also American Association of Industrial Standards. It consists of several levels. The top level includes business intelligence systems, mass systems, medium level, so-called SCADA systems or APCS systems, operator stations for controlling the processes or applying certain changes to the processes, HMI panels, servers, historical data accumulation. The lowest level usually includes computing systems which directly control the process equipment or receive data from sensors. It's like PLC controllers or UGA or some other industrial devices, industrial computing systems which are dedicated for direct contact with the equipment or as control activities or for the information from sensors and equipment itself, of course. Well, as for the top level, it's not a part of questions being discussed right now, but for it, well, there's a lot of things which are being developed for it. It's an office system and many other systems of info protections, and they all are adequate. But what about the lowest level? There are certain peculiarities that I was speaking about in my first slides. And this is where we see the main differences from the office network. And due to the fact that we also have the computers here, they have to be protected. But the measures of protection and approaches of protection, they should be different from the office ones. And first of all, the main thing is that they have to guarantee us with continuity of surveillance, continuity of control activities over the process equipment, and means of monitoring of informational process. Well, the APCS network is also a computing network. There are nodes which exchange information with each other, and adequate measures of protection are measures which both monitor this information and do certain analysis of it or can filter this information afterwards. In addition to all of this, we should take into consideration the fact that situation with APCS is such that we have no two similar facilities, and because the life cycle of those APCS systems is much longer than of the office systems. For example, if the office system, the full cycle of its utilization, the full cycle of upgrade of the software, you can imagine is approximately 1 year, in some cases 2 or 3 years. Well, let's say that in most common systems is 2 years. So in APCS systems, these life cycles can be measured in, well, 5 years. It's a minimum. It's the fastest upgraded APCS. There are systems which work 10 years or even longer. What does it mean? It means that in the time of its life cycle, these systems go through planned maintenances, upgrades, some equipment has been decommissioned and replaced by new upgraded equipment, and those models that were produced 5 years ago, they don't exist, so another equipment is being installed, other integrators come to the company, so it's a very big period, and due to the fact that it's a very extensive cycle, most of these systems are very big, and they have a big combination of equipment from different manufacturers, different types of software installed on them. And those people who do face and who do work with those APCS systems, they don't understand the situation. So due to the fact that each of these objects is unique, it's very difficult to foresee some out-of-the-box software that you can buy a license for and install it once, preset it once, and forget about it forever, thinking that measures of information protection are adequate. Well, they will stay the same. for a period. Protection of the APCS systems is a certain process which requires constant attention from our side. So with a certain frequency, we should do the investigation, we should do the audit of the situation with the threats, because the situation is constantly changing and we have to take it into consideration. And I'm telling you this because measures of info protection, they do require additional services and requirements. So you should have very qualified specialists and organizations which will take this process of supporting information protection, and they will keep this process on the top level, on the highest level of defense. So right now, speaking about the properties, I have listed 3 different aspects, like protection of industrial desktops, means of monitoring, protection, and services. Which, well, every organization should have means of protecting their endpoints. First of all, the most important requirement to this protection equipment and hardware and software, and because we've been speaking about providing the continuity, this informational protection means for them the most important thing is to provide faultless operation of the main operational software. What does it mean? It means that this software and hardware shouldn't interfere, and there should be forecasted and normed usage of resources of the computer, processors, and memory, and file. So at every specific moment of time, we should know how many resources are needed to start work the informational protection. Only in these conditions you can design a good automated system which will behave properly and predictably. These technologies include technologies which are listed here. First of all, it's whitelisting technology. It's a so-called technology of creating a closed software environment. The technology itself can be described by a certain process of settings or training which requires a high level of qualification and the resources of computer. Another one, the real operational mode. In this mode, we can guarantee which level of resources will be consumed and which ones of them can be defined as the standard ones, which resources will be consumed by this technology, and this is a very important property of it. So during settings, configurations, and the work of regulations, we can do all necessary works in order to tune up this whitelist, and then after this work, we will have a small and normalized usage of resources. Control of device connection. Device connection control. Well, usually in existing APCS systems, connection devices control is done on local level. In most of the facilities where we had a possibility to do some kind of trainings or studies, they had certain documents according to which a person couldn't take in flash card or connected flash card. In some cases, they've been locking USB ports with certain markers. Sometimes they were disconnected on the level of BIOS. Different measures have been taken. But I never seen that they didn't have any incidents with the usage of mobile devices, this or that way. People do find possibility to bring USB flash card, and during the night shift, when technological process is being done softly and evenly, an operator should only carefully look at the screen and do nothing else. Well, it's the best time when top management leaves, look at some pictures on the computer, from the weekend, shish kebabs, or watch a movie or something else. So these technological measures, they add to the regulated measures, to the standard ones. So from the point of view of regulatory measures, which have to be clearly defined for the people of the company, and from the point of view of technological control of these technical specifications, this is also should be a good measure of providing them with whatever they need. And as for regular technologies, heuristic and signature-based technologies, these are also adequate measures, but these measures can be applied due to the fact that application of these technologies, when these technologies are being applied, we cannot regulate resource utilizations, and they can be applied only during the annual maintenance, but not in work condition. Similar technologies related to search for vulnerabilities and other ones, they also are necessary in order to be able to create this closed network, which is going to be controlled by this whitelisting. And in order for this network to be adequate, proper one, and that it wouldn't contain any vulnerabilities or any problems, well, for this you can use these prophylactic methods which are used during the common maintenance operations. Well, right now I would like to say a couple of words about networking information analysis. The main requirement here is similar like to other, is not to damage. So adequate application of this is a proper work, but those info flows and those processes of communication which are inbuilt inside of those APCS systems, they can be described by large complexity, big volumes and large complexity. In other words, if you want to understand what happens in the network and if there are some unallowed processes are happening in the system, some non-specific events are happening in the system which you were not able to see, well, it's not so easy to detect them just by simply looking on a screen. For these purposes, we have special technology for analysis of networking operation. What is important to be pointed out here is that, first of all, in APCS systems, as base, we apply technologies which are really common ones, and I've been mentioning them: TCP/IP protection and HTTP protection technologies, very common and well-known technologies. But on top of these common protocols, some use protocols specific for industrial systems, Modbus, Profitbus, Protocol 16850, and big number of other protocols are used. And for these protocols, we need adequate measures of analysis and protection, because these means of analysis, at least they should understand those protocols. Another important thing is that these control systems according to our understanding. And right now, there's a big community which exchanges information about it, and this community comes to a number of conclusions that these informational systems cannot be looked as purely informational systems, because in order to understand processes which are happening there, and then if you want to be able to prevent negative influences, these systems should be looked at cyber-physical systems. And there's a common term, cyber-physical systems. So it's not enough, if you want to properly analyze a situation, if you want to properly analyze information that has been exchanged between those nodes, you shouldn't just simply parse the protocol, and you shouldn't just simply understand that a certain command for closing the valve is being given, or to turn 30 degrees by the robot. But you should also understand that this information can lead to technological process violations like destroy of the equipment, which means, first of all, this information could be available only to those people who understand technological processes, technologists, engineers who develop this equipment and software. But if you want to analyze this information, especially speaking about information flows, only specialists could do that. Specialists who develop the means of monitoring and analysis. In other words, I come to the conclusion that adequate measures of protection can be developed only together with specialists from info security department and specialists which know technological processes, because technological processes are different from company to company. These specialists should be chemics, chemicians or physicians, or those who provide transportation or any other specialists. And this analysis that I was speaking about, this analysis should be based on information which is going to unite these two worlds. And this is a very difficult objective. If we want to see those specialists in our companies, and if you want to build relations between these specialists and specialists of a totally different area of knowledge, well, sometimes it's a very untrivial and difficult objective to achieve this cooperation. But these systems, they do exist, and Kaspersky Lab develops programs like that. And these programs, if you will pay attention to this scheme, in red color, you will see equipment which does the analysis, and it's installed in such a way, and right now it's a very strict requirement which is predefined by the fact that we have to provide continuous technological processes without any destruction. So we have developed means which analyze not the information itself which circulates between this networking device, but analyze its copy. So with the help of networking devices, they made a copy of this networking information, and we do analyze this copy. And in some words, I think that this technology is not able to protect. From the first sign, it seems that if you use such defense technologies, we'll be able to provide big threats, but in real life, they are not able to do so in full scale. And out of common practice, we can see that surveillance cameras and specialists are still arguing. For example, a surveillance camera is a means of monitoring or means of protection. Can they or can they do it? We have the same situation monitoring, which is not able to violate technological information processes. And second of all, they can do a very fast analysis of this networking information, and this analysis is becoming visual for the servicing people in the company. So on the basis of those rules of analysis that were defined for every specific facility, we can come to the conclusion that in the informational network we can see certain processes which shouldn't happen there, and this information should immediately become available to the servicing personnel. Why this is important, and why can this prevent accidents? Well, it seems that the influence against EPCS system, it should be a one-time short influence, and it immediately will lead to the incident. Well, it's not true. And our experience tells us that we need to find processes of informational integration between different facilities, and all facilities are unique, and you can influence them only after the criminal will collect certain information. You can only react and not proactively do something. So at early stages, we should be able to discover those attacks. At the initial stages, we should be able to discover threats and attacks, and administrators should provide certain measures which are going to neutralize or prevent. Well, as I've told you previously, all these technologies are non-invasive technologies. This is not in building into existing information process, but this is external monitoring. So being more specific, with the help of these technologies, one can discover changes in network configuration. One can discover changes of the character of interrelation between the nodes of the system. And as I've told you, on the basis of those rules, which are defined by technologists and technical specialists, well, we can understand that the team sent to work with the equipment in certain conditions is not able to work with it and can lead to certain negative consequences. Well, in addition to that, speaking about services, which are adequate for being applied in these systems. Well, everything starts with the research, with the audit. You cannot defend the facility without audit and knowledge of adequate measures of protection. So first you have to do the audit, and then you can do the work. Well, on the basis of this information, forming of models and possibilities, opportunities, and on the other side, risk analysis. Because people from the Information Security Department, they should make it clear for people who make decisions, all possible risks should be verbalized to them. But if you want to select among those risks those which will be neutralized by particular measures, it's a joint work process. One can select risks which can be defined by the information security measures, some risks by physical security, and some risks can be considered insignificant and no actions will be taken against them. But this is a iterative process of our work between us and business owners or project organizations. Up here you see very common services like technical support, training, informing, and the list of services is a rather big one. Also would like to say that Kaspersky Lab, in the course of a long period of time, is involved in regular reports about the condition in the info security area especially. We have started getting involved in looking at threats and incidents and vulnerabilities specific to APCS systems. Also, in the Kaspersky Lab, we develop special measures of protection from targeted attacks, but this means dedicated mostly for organizations. For those organizations which have the APCS systems, they have certain peculiarity in applying these technologies. And as I've told you previously, training. We have developed a full number of training courses. We have developed a game, simulation game, whose main idea is to defend industrial water cleaning station, which includes all the equipment that we've been speaking about, like controllers, sensors, and which is under control of different external factors, which can lead to its instability. It's a game, and we have two options of this game. It's a water cleaning station and a diesel power plant. Well, that's all I wanted to tell you. I will gladly answer your questions if you have any. Thank you very much for your attention, then.